All right, today we're going to start into 2.4. Starting with the opener that's here, talks about, wants to know, is it true or false? True or false? It is possible to draw multiple distinct lines through 2 points, A and B. So if I make any 2 points here, I'm going to make these 2 points. I'll make one here at 1, 1, and I'll make one up here at negative 2, 3. It wants to know, can you make multiple lines through those same points? So I make my one line through them. And it wants to know, can you make multiple ones going through them? So there's one. So essentially it wants to know, can I make these maybe wider? And then take my line, and now it goes through this portion of it. Right? Or make them even wider after that, maybe. And then make another line going through them. So now that I have 3 lines. Because to be a distinct line, it means that you have to be able to tell the difference between them. Right? So when you're looking at this, the idea is, my point is actually this little finite thing that's here. So to go through those 2 points, there's only going to be one line that will do that. So our opener is false. It is not possible to draw multiple distinct lines through those 2 points because your points have no dimensions. They don't have a width or a length to them, so I can't make them bigger. Right? And one of the things we're going to get into today is going through these basic ideas and our building blocks for our beginning postulates of geometry. And that's really what we're going to look at today. Our first one is when we talk about a line being perpendicular to a plane. It says a line that intersects a plane at some point. And it is perpendicular to every line in the plane that intersects at that point. So it is a line that intersects a plane. So it's kind of a line that goes through, if this is my plane, it is going to be a line that goes through there. Remember, so I'm going to go through it, and I'm going to intersect this point here, and then I'm actually going back behind it. So it is a line that intersects a plane at a point. And it is perpendicular to every line in that plane that goes through that point. So if this line was perpendicular to my plane, it's going to be perpendicular to this line. It is going to be perpendicular to this line. It is going to be perpendicular to this line. Any line that we draw in. All right. Now, postulate 5. Postulate 5 says through any 2 points, there exists exactly one, and we went over this in the opener, there exists exactly one line. Now, you'll notice postulate 6 is actually the converse to this. It switches our 2 ideas. Here we're saying that if you have 2 points, then you have one line. Postulate 6 says, well, if you have one line, then you have at least 2 points. So these 2 postulates really have the same idea, but it's which part do you have first? In postulate 5, you have the 2 points first, then you have the line. In postulate 6, you have the line, which means then you have your 2 points. Now, postulate 7 is actually number 1 from your chapter 1 test. If 2 lines intersect, then their intersection is exactly 1 point. 2 lines intersect to form a point. It's one of the things we learned in chapter 1. So those are our first 3 postulates here of the section. Now the next one talks about our planes. In postulate 8, in order to have a plane, we have to have at least 3 non-collinear points. So through any three non-collinear points, there exists exactly one plane. So here I have the three non-collinear points, then I have my plane. Postulate 9 takes those two ideas and flip-flops them, just like we did earlier. So postulate 9 is going to have the same idea, but which piece is given to you first is the difference. So postulate 9 says a plane will consist at least of three non-collinear points. Remember, non-collinear points are things that look like A, B, and C here. So postulate 8 and postulate 9 say very similar things. It is all about what is given first. Are you given the non-collinear points first, then your plane? So that's postulate 8. Postulate 9 says if I have a plane, then I have my three non-collinear points. Now, postulate 10 says if 2 points lie in a plane, then the line that contains them will also lie in the plane. Right? So if I have a plane here, if I have 2 points on it, then the line that contains those 2 points will also lie on that plane. That's all it's saying. And then finally our last one. Postulate 11 says if 2 planes intersect, then their intersection is and this goes back to number 2 from your chapter 1 test. The intersection of 2 planes is a line. Oops, sorry. There we go. So the intersection of 2 planes is a line. All right, take a look at take a look at example 1. It says state the postulate illustrated by the diagram. So, taking a look at what's there. If we have 3 points A, B, and C, then we have plane ABC. When you look back at our postulates we've gone over, there are 2 of them that talk about 3 points in a plane. One says that if you have 3 non-collinear points, then you have your plane. The other says that if you have a plane, then you have at least 3 non-collinear points. So the order matters. So we're looking at postulates 8 or 9. Here we have the points coming first, then our plane comes second. So the postulate we're looking at then is postulate 8. As far as postulate 9 then, there's 2 questions to it. It says use your diagram to write examples of postulates 9 and 11. So postulate 9 says plane blank contains at least 3 non-collinear points. So if I look, I have 2 planes in my picture here. Those 2 planes have a very specific name for each of them. Remember, you name a plane with a capital letter in one of the corners that does not have a point or a dot next to it. If it has a dot, then it is a point, not the name of your plane. So the shaded plane is plane Q. The non-shaded plane is plane P. Now, one of those will contain 3 non-collinear points. If you look at your non-shaded plane, if you look at plane P, the only points that are there are X and Y. So there were only 2 points on that plane, so I cannot name it. Instead, we have to use Q. So plane Q contains at least 3 non-collinear points. So now we need to look and figure out what are the 3 points that are on my plane. Looking for your dots, I got point V, I got point Y, and I got point W. Oops. So points V, Y, and W are my 3 non-collinear points. If you look at postulate 11, postulate 11 says the intersection of plane P and plane Q is two planes intersect to form a line. And this specific line we're looking at here is this line right here, which is called line B. Brings us to our last example today. Take a look at that diagram. In geometry, there are certain things we can assume are true, certain things we cannot, and that's what we're going to talk about here. It says, which of the following statements cannot be assumed from the diagram? Points E, D, and C are collinear. So if I look at E, D, and C, is there any doubt that they are collinear? No. The first one is good. In number 2, the intersection of my 2 lines, BD and EC. So here's EC. Here's BD. The intersections of those 2 lines is point D. Well, that works too. Your third one says that BD is perpendicular to EC. When I look at this intersection, is there anything there telling me that I have 90-degree angles? Perpendicular lines, perpendicular planes, the ideas of things being perpendicular, you are never allowed to assume them. There has to be some type of marking there. Specifically in this one, we're looking for that little right angle mark, but it's not there. So I cannot assume that it's a right angle, or that those lines are perpendicular. Likewise then, that fourth one, that EC is perpendicular to plane G. So once again, when it comes to things being perpendicular, you cannot assume that things are perpendicular. Brings you to your homework here tonight. Pages 99 to 100, numbers 3 to 10, and 14 to 24. All right, have a good day, everyone.